Welcome on this new episode of Let's Talk. I'm super happy to be here today with Maxime Labonne. Maxime, how are you doing?
I'm good. Thank you, Thomas, for the invitation.
And thank you for being on the podcast and taking the time to be here with us. That means a lot. I have many questions, like always in every episode. For everyone who is tuning in, we deep dive into AI and data topics. Today we're with Maxime Labonne. You have a very impressive career. Maybe for the people who might not know you, could you do a brief introduction about yourself?
Yeah, sure. So I'm currently a staff machine learning scientist at Liquid AI, where I'm the head of fine tuning, and I have a PhD in machine learning from the Polytechnic Institute of Paris. And I'm also a Google developer expert. It's quite recent.
Awesome! Congratulations on this last one.
Thank you.
So, I think what I always like to do at the beginning of the episode is what is the state of the art of Maxime Labonne? So, what do I mean by that? What are you most curious about those days and in the previous months? And I'd like to understand where is your attention at. I know that there are some things that you can or cannot disclose, but whatever you can share with us that you're super curious about today would be super interesting for everyone.
Yeah, sure. I think that my interests are really related to fine tuning and all the post training stuff you can do with models. So, super interested in ways we can evaluate the data. We saw that it's really a major component. It's machine learning, right? So, you always learn from the data. That makes sense. Evaluating models is also challenging and has been like quite difficult in the past, but we see like new techniques, new frameworks that can make it better apparently. So that's quite exciting. And in general, I would say like all the field of model editing, where you take a given model and maybe you're going to merge it, maybe you're going to prune it, all these kind of experiments that you can do with existing models. I think there's a lot of untapped potential in this area because of a lack of tooling and maybe a lack of interest in general. But this is growing this year, so quite excited to see what we're going to see.
Amazing. And my follow-up question to you would be, can we do a little throwback and go on key milestones of your career? And if you can share some insights since maybe the university for you or your PhD, so that we can capture key moments and that everyone have a clear idea of what you've been doing.
Yeah, so I've started in cybersecurity actually. That was my education, I would say, which was computer science with a strong focus on cybersecurity. Then I started a PhD in machine learning applied to cybersecurity, and I realized that I like machine learning a lot more than cybersecurity. So I decided to just move into AI instead, and this is what I've been doing after the PhD. First at Airbus, where it was mostly applied to computer networks, and then at JP Morgan, where I was there really to implement LLMs. And I recently joined 3 months ago Liquid AI to be the head of fine tuning.
Awesome. Okay. So I think that now that we have a clearer picture of what you've been doing, clear, high level, let's say, I would be super curious to ask you about your contribution to open source, the courses that you've been doing, and everything that you create online. So could you comment about maybe how you got interested in AI, ML, and so on, and like why you did this switch, and which tools, like, did the open source play a big role on your transition? How did you upskill? How did you learn what you needed to understand to grow your career and follow your curiosity? So I think there is like your growth. Where did you learn? And if possible, understand the open source role in this big picture.
Yeah, open source definitely played a major role in this switch because I realized that there was a lot of content that you could find in the open source about AI, about machine learning, which is not necessarily true for cybersecurity, or at least you don't find that many high quality resources. And I was very interested in this stuff. So when I saw that there was so many great articles in machine learning, I started really reading everything that I could, everything that was related to my PhD. I really enjoyed that. I really enjoyed the open source community that you find in AI. So that also motivated me to contribute to it afterwards.
Hmm. Awesome. So how did you got started on Hugging Face? I think is one thing that, for example, if today I see all the models in Hugging Face, and I want to try and use them, um, I think I'm super curious to, well, first of all, large language models, and then Hugging Face, and how do you end up publishing and building the course, and what drives you behind building this content, if I can follow up on what you were just mentioning.
Yeah, I've started using Hugging Face like very early on, actually, like during my PhD when it was not called Hugging Face, yeah, um, I've had a long relationship with with them and their tooling. I think this is great because they provided a lot of tools that allowed people to get into LLMs and machine learning in general. And this is, I think, a very inspiring philosophy
Mhm.
to lower the threshold, so more people have access to these tools, and you can have like people from different horizons, a lot of creativity a lot by that. And even for researchers and like I don't know, hardcore software engineers, I think that it makes them a lot more productive because these tools are a lot more user friendly than using raw CUDA, for example. So this is what I've tried to replicate at my level with the LLM course, for example, on GitHub. This has been like quite popular. So to describe it very briefly, it has three different roadmaps for people who want to get into LLMs. There's the first one that teach the fundamentals. It's not going to be like super relevant for a lot of people because it's math, Python, and these kind of basics that you need to know to really thrive in this environment. But otherwise, you have an LLM scientist roadmap that gives you all the major things that you need to learn to really get into the science behind LLMs, how to create the models. And there's another roadmap, which is the LLM engineer roadmap. And this one is more about deployment, it's more about how to look at models as part of a broader system. So, like RAG and this kind of stuff, agentic AI too,
Mhm.
and how to build systems based on these LLMs.
Hmm. I'm super curious to ask you about agentic. I think that your course have 30K stars or around 30K, and we'll put it in the link if anyone have the curiosity and haven't seen it yet to learn from the different three paths I just mentioned. Um, you have a strong expertise in LLMs, and you've been doing this before it was hyped, if I could say. So I'm super curious to ask you about what misconceptions people have when they want to build tools around them, or when they want to do fine tuning, or do any kind of training related to those big models. I don't know if you have some key ideas around misconceptions that we can have, or that you've seen repeatedly and you're like, okay, these need to be said. I don't know if you have any thoughts on that.
Yeah, I have a long list of misconceptions and mistakes that are quite frequent in this field. First, I want to say that we always thought, well, I always felt that LLMs were very trendy. It's just that it keeps becoming more and more hyped. But even in 2019 and 2020, it was already quite hyped, really. So this thing just keeps getting more popular. But about the misconceptions, I think that what I often see with people who are more into the engineering side of things is that RAG can solve all your problems, and you basically don't need fine tuning. I think this is not true for like many reasons. Because, well, first they use fine-tuned models, so fine-tuning is also important to them. But also, usually you have a precise use case. You don't want to necessarily do general-purpose models, and in this case, you always benefit from retraining the model on your domain or on your precise task, and then combine it with RAG to get the best results. I would say start with RAG, and if the performance you want to improve them a little bit, you can move on to fine tuning and combine it with your RAG pipeline. So this is one common misconception I have. And the second big mistake that I often see is about the data that these people use, mostly for fine tuning, because we often have raw data, raw text, but we rarely have instruction data sets where you have pairs of questions and answers. This is what you need to do fine tuning. So oftentimes it can be like quite difficult for people to understand like how I take this data and I create an instruction data set fit for fine tuning. Um, there are some answers in the LLM course and in the LLM datasets repo that I've made with tools such as Distillable that allow you to automate like a lot of this process.
Awesome. There are many directions that I want to take from this. And I think the first one that comes to mind is directly going to evaluations. So you mentioned, okay, build a RAG. Then if you want to improve the performance of whatever you're building, consider fine tuning on your data and combine it with RAG. And then in RAG, there are many techniques to optimize. So I'm super curious to ask you about the evaluation part of those models. There are different techniques out there. Everyone is talking about perplexity of the models, and I was super curious to ask you just that. How do you approach evaluation and building those data sets for evaluation?
Yeah, evaluation is quite tricky, and it really depends on what you want to build. Because if you have a very task specific model, for example, you want to do translation, then it doesn't make sense to use general benchmarks because you just want to do translation. You don't really care if the model is able to reason well, is able to do math, or all you want to know is a model that can translate it from one language to the other. So in this case, you want to look at open source evaluations. There are a lot of leaderboards on Hugging Face, for example, that implement this kind of evaluation that are really specific to a domain. Could be finance, could be healthcare, or a task, can be translation, can be summarization. Those are a lot better than just using Perplexity, for example. They're a lot better than using traditional uh, machine translation scores, unless you do machine translation maybe, but like a Blue score, BERT score, this kind of stuff that we used to use a few years ago. They're quite outdated now. We have better metrics nowadays. So I would recommend that. And if you're more interested in a model that can do a bit of everything, a bit like ChatGPT, then it might be good to look at the open source, the Open LLM leaderboard, to look at LMC's chatbot arena, where they make models compete with each other, and that gives you a good understanding of what would be a good chatbot, a good model that can do math, a good model that can reason with stuff. So basically, it really depends on the end goal, what you want to do with your model. Is it a chatbot that can do a bit of everything? Is it a model that has a narrow task? And based on that, you can either reuse open source evaluation sets, or you can build your own if you have a very specific task. For example, you want to do a translation, but like with very rare language. So in this case, you might take inspiration from these open source evaluation sets and create your own in this language.
I see. And so following up on the evaluation side, if I, for example, build a RAG and I have or I haven't fine-tuned my model yet, but I would be curious to know how, like, do you approach evaluation on a RAG of specific internal documents, for example, in the same way using open source models? I would assume no, because you want to verify that the information that is private to you is retrieved correctly. So how do you approach this specific kind of problems when people are working with their own data and they want to try to test their systems and not only like the capabilities of the models through open source data sets, evaluation data sets?
Yeah, you can also evaluate RAG pipeline separately. First of all, like what you want to do is really you want to evaluate the end results. So with RAG or without RAG, you should have the same evaluation data set that can tell you if the model is behaving correctly or not. But you can indeed precisely look at some metrics for the RAG pipeline, like precision and recall, to make sure that you are actually retrieving the right documents for a given query. And based on that, you can optimize these metrics separately, because you like one of the most common advice with RAG is to give as much context as possible to the model. And instead of doing just vector search, maybe do hybrid search. This kind of stuff can be optimized independently of the model almost. So you have a really strong RAG pipeline, you have a very strong model, and when you combine them, hopefully it should also improve your results on the overall benchmark.
Awesome. And you mentioned hybrids, not only doing like vector store retrieval. Can you say more about what is hybrid and like how would you approach it? Like what does it take into account?
Yeah, we have traditional, I would say, keyword-based search, and we have vector search. So vector search, you're going to use embeddings provided by machine learning models to retrieve it based on metrics like cosine similarity. And you have the traditional information retrieval field that has like really good search algorithms like BM25, and oftentimes they're like really strong baseline that are difficult to beat with vector search, especially if you give a lot of context to the model, because it makes it better actually with the traditional search algorithms. So when you do a hybrid search, you're going to merge the result of both of them, and that has been seen to be the best performing technique, because you can have like the precision of the keyword based search, and you also have the fuzziness provided by the vector search.
Awesome. Thank you very much. Coming back to the fine tuning, which is, I guess, your favorite part of all this, um, the ML space. So I'm super curious designing data sets for fine tuning. You mentioned that it can get quite complex, but I don't know if you can comment on the key points that people overlook or that most interests you in terms of building these data sets so that you will start fine tuning. And like, how do you do it in an augmented way? For example, do you have a GPT-4 building the data set with you and iterating? And how do you make sure that the data is distributed? How do you make sure that it won't start to act weirdly? I don't know, all these kind of things that I can think of.
Yeah, I think that the first step that you want to take when you do fine tuning is to look at open source data sets, because there are a lot of high quality open source data sets. We know that they're high quality because they created high quality models. So it's really like the best way of evaluating data sets is to look at the model that they created. So you have to just make a list of everything that is relevant to your use case. It can be very general purpose data set like Slim Orca that can do a bit of everything. It can be something very narrow, like we talked about translation. There are a lot of data sets about translation too. And you want to probably combine them, combine the best of them at least, because quality is a lot more important than quantity, sorry, for this kind of task. So you want to have um, very high quality samples. And on top of that, you want probably to do some kind of filtering. It can be keyword based, like I don't want um, uh, URL links, because we know that models tend to hallucinate when they try to create links. So you can remove everything that has HTTP two point slash slash, for example. That's a way to do rule based filtering. You can do some kind of fuzzy filtering with min hash, for example, where you're going to deduplicate the data set to remove samples that are too close to each other. So in this case, you promote diversity in your data set by removing samples that are too close to each other. There are a lot of techniques that you can apply like this to improve the quality of the data set. One of them, on top of all these heuristics, is to use an LLM as a judge. And you are going to prompt the LLM to rate a given sample. You can give different dimensions to this rating in terms of like quality, complexity. You can find a lot of these kind of metrics. And based on these scores, you can filter out samples that are considered to be low quality. Different techniques in this field can be done by GPT-4, for example. It can be done by Llama 370B Instruct, or it can be even done by a jury of different models. And then you can use all these predictions, combine them in a smart way, and filter out bad samples based on that. Once you have done all of that, maybe you still want to create more samples uh, because, for example, you realize that the model that you have fine-tuned on this data set is not good in math. So in this case, you can just pick more math data sets, or you can create your own. And you mentioned the fact that you can use GPT-4 to do it. So you can create synthetic data to augment your data sets. Basically, most of the open source datasets are somehow synthetic. Like over 90% of it is synthetic data. Has been shown to be very high quality too. So this is not really a problem. And to do that, you have tools such as Distillable once again to create more data based on other models.
I see. And when we're fine tuning with proprietary data, is it the same approach, or like does the companies, for example, need to build their own data sets that will be combined with other data sets? So let's say I want a model that is good in math and that is really good in my expertise, whatever industry I am in, and using the documents that I have in my company. So I would assume that you need to build your own data sets and you can't only use open source ones. Am I correct? Am I wrong?
Yeah, you can definitely just use your own data set, proprietary data. You can refine it, as I mentioned earlier, with like transforming it into instruction data sets. I think it's a good idea to combine it with open source data in general. You can have very general purpose data sets, because if you use a model like, I don't know, Mistral 7B, for example, you want to fine tune it. It's going to help the model if you don't have only like your task, but a bit of like general purpose data. One reason is because it makes the model better in general, including on your task. And the other reason is that maybe you don't have enough samples. If you have just like 1,000 samples, it's not going to be enough for a 7B model. So you might want to augment it with more data, and that way the model is going to also learn the chat format, so the format that is used to interact with users a bit better than if you just restrict it to your proprietary data.
Got it. Thank you. Um, Following up on that, I'm curious about the size of these datasets when you're doing fine tuning. So, and I'm sure this is in in your course, or in some recent posts that you've done. I'm curious, depending on the size of the model I'm going to fine tune, you mentioned Mistral 7B, or a bigger model, how big does my dataset need to be? So, like, is there like a proportion based on the billions, or doesn't have to do with that? Because I want to like share it different kind of tasks, and like not only my data. How big should I optimize the data sets based on the size of the open source data set I'm using it on? So like Mistral 7B, like you said, for example.
Yeah, there's not really a silver bullet for that. I can't say like, oh yeah, you need to use like 1% of the number of parameters, for example, because it really depends on the quality of the data too. If you give a lot of low quality samples, it's not going to be the same thing that if you give just like 1,000 high quality samples. We saw that with big models, they tend to be able to extract information from the data more efficiently. So they're more sample efficient than small models, which is why 1,000 samples might not be enough for a 7B model, but it might be enough for a 7TB model. This is an experiment from the Lima paper that was released in 2023, for example. And based on that, you want to probably do some experiments to make sure that you have enough samples, knowing that it's probably not a good idea to have like 1 million samples or 10 million samples. If your use case is very narrow, if it's translation, you might need fewer samples. If it's general purpose, then it makes sense to have 1 million samples. We know that Llama 3 has been fine tuned on 10 million samples, according to Meta. So it can get really, really big. But the bigger the data set, the more costly it's going to be. And that's also one of the reasons why you should only focus on high quality data, because it's more costly otherwise, and it also makes better models.
Awesome. Okay. I think I'll take a tangent here. I'd like to go towards graph neural networks, or graph knowledge graphs, and how do they combine with large language models or RAG applications. So I just saw that deep learning on their website, they have a new course where it includes long graph and some other tools that I'm not sure to remember exactly. You also wrote a book about graphs, neural networks. If I'm mistaken, correct me, please. So I'd like to ask you about both the process writing of the book and graph neural networks in general, and how do they combine with fine-tuning, LLMs, and so on?
Yeah, so indeed, I wrote a book with Packt about hands-on graph neural networks with Python. That's the title, and the idea was to provide a very practical book to implement graph neural networks, major applications, major architectures. This is very connected to LLMs actually, because graph neural networks are a very general architecture, and you can easily say that the transformer architecture that currently powers all the LLMs is a type of graph attention networks. This is what graph people like to say anyway. And you can see a lot of similarities in how they operate. I think that, for example, learning about self-attention is a lot easier if you look at the graph attention network instead of the transformer architecture, which has like a quite refined version of the self-attention mechanism. So about the writing part, I've been contacted by Packt because I've published a few articles about graph neural networks on my blog and on Medium, describing a few architectures, and they asked me, "Are you interested in writing a book about this stuff?" I thought about it. I thought that there was like enough architectures, enough task use cases to write a full-fledged book about it, and that's really how I started it. So the final book is really about PyTorch geometric, how to use this library to implement graph neural networks for your use cases. It can be recommender systems. This is the main application of it. It can be something in traffic forecasting. It can be anomaly detection applications. There are really a lot of applications that are powered by graph neural networks currently.
Okay. And would you say that so graph neural networks is different from knowledge graphs, but I was curious to ask you about, for example, when you think about combining knowledge graphs in RAG systems, for example, with an LLM, I personally am not sure. Sometimes I'm not so I'm trying to get more into the graph. I mean, I know some people have been for decades, so I don't want to upset anyone here. But I'm curious to ask you about. Have you seen some interesting use cases that leverage knowledge graphs combined with LLMs and RAGs applications?
Yeah, so knowledge graphs are a type of graph where you have a relationship between entities. So you can use it with graph neural networks, for example. This is also a popular way of doing it, because the problem with this knowledge graph is that usually they have millions or billions of nodes, billions of edges. And so your graph is so big that you don't actually have all the connection between nodes. This is a popular application is when you use Google search and you type the name of an actor, you're going to have suggestions from Google about like the movies where you can see this actor. And this is powered by their internal knowledge graph. And you can see that, okay, like the connection between an actor and a movie is quite obvious. It's just like one link, but maybe it's quite difficult to ask Google, okay, like, can you tell me a movie where the cousin of this actor has played in like the 90s? Because then you have several hops to do to get to the information. And this is why you can use graph neural networks for that, because they can actually predict connections between the nodes. So this is a popular application. When we want to implement it with LLMs, it makes sense because you can basically use it as a RAG system where you're going to input a query, and this graph neural network or just like general graph database can give you the answer to this query, but by querying the knowledge graph. I think that people right now, they try to maybe implement it, from what I see experimentally, with small knowledge graphs, where it doesn't necessarily make sense, because if you have a small knowledge graph, you can probably just use like a NumPy array, and with you can basically give all the different connections, and that would be probably a lot better. Instead, if you have a real big knowledge graph with billions of connections, then it makes sense because you cannot map all the connection, all the relationships. So in this case, you might want to use a graph neural networks, for example, to predict the links between two nodes and give this result as input to a large language model, so it can reason over that and provide a better answer.
Awesome. And so you've wrote and described a lot of architectures of graph neural networks. What are some takeaways that you want people to remember, or when you do conferences or talks, or when you chat with your colleagues? What are like the main things that comes out from hands-on graph neural networks using Python? Are there like key pieces or concepts that people misunderstood that you hear often and that you come back to explaining a lot?
Yeah, the first one is that in graph neural networks, the graph is the input and not the neural network. I think this is the main misconception. When you start hearing about graph neural networks, you think that, okay, like the graph is the neural network, but no, the graph is the input. And a graph as an input is really good because you can pretty much represent like a lot of data in terms of graph. It can represent an image in terms of a graph with every pixel that is connected to the neighboring pixels. You can see a sentence as a graph because every word is connected to the previous one. The transformer architecture exactly does that. Like it connects every word to every other word to calculate the attention score between these words or these tokens, and you can use it with data that is just like uh, items and users for recommender systems, for example. So that's a first point. And in general, I would say that graph neural network is quite an elegant architecture because it's very general. So if you are good with graph neural networks, it will allow you to understand pretty much any other neural network architecture because it's just like it's a bit. Most of them are just like very narrow application of graph neural networks. Like, okay, oh, now I have an image, so I'm going to use layers that are very focused on images, but it's basically the same reasoning. So it's quite a general purpose and elegant framework to learn more about neural networks in general.
Mhm. I see. I see. Um, I think that what I would like to follow up on, I'm between going on the career side or making more neural networks questions. But I think we can come back to it later. Um, well, no, actually, I'm super curious to ask you that. So transformers, I would say, are number one right now. So do you see any architecture or systems that could challenge, or any technology that you've been curious about that you're like, okay, transformers could be second looking at this architecture or what's happening in this specific area of researching?
Yeah, it's true. Transformers are pretty much everywhere in the LLM space right now, but we see a trend of new architectures based on recurrent neural network or based on state space models. Those are the two main competitors to the transformer architecture. And you don't have to see it as one or the other. It can be a hybrid model. We have like different models that have done that. Striped hyena. We have the Jamba model where you can combine different layers. For example, in Jamba, you have a lot of Mamba blocks, so a type of state space model. And every, I don't exactly remember, every 7 or every 8 member block, you have a transformer block. So it's mostly an SSM architecture, but just with a few blocks of transformer layers. Why that? It's because you manage to bring the performance that SSM give you. They're just faster to train. They're also faster in terms of inference. And you also have the benefits from the attention mechanism, which really stores everything in memory. So you have all the attention scores between all the tokens in your history. That's very good if you want to do recall task. Because in this case, the member architecture, the SSM architecture is not so good with that because it compresses the information into state spaces. So by combining these different architectures, I think that we have a good recipe to go forward with architectures that are lighter, more efficient in general in terms of training, in terms of inference. So I find it quite exciting that, yeah, we slowly maybe moving away from the transformer architecture. At least that would be my bet.
Amazing. I could ask you about compute. Oh, well, okay. So I think before going into the career side, I would be curious to learn a little bit further about maybe some latest reading that interested you. I don't know if you've read some paper recently or that you've worked on something. I know that I asked you earlier about what are you curious about those days, but if you have like some ratings recommendations, book recommendation, not only like recent, like books that you always come back to and that you really enjoyed. Um, I think, yeah, some resources and maybe thoughts that you had on something that you read recently or not.
I think that very recently I found out about it's a paper, but it hasn't been released yet. It's going to be released soon. It's called MixEval, and then MixEval, you have the idea of using existing benchmarks like MMLU, GSM8K, and all the benchmarks, and you combine them in a smart way by sampling all of them. And basically, they managed to do an evaluation dataset with only 1,000 samples that is highly correlated with the LMC's chatbot arena ELO, 0.96. So it's very high correlation, and it allows you to get a very good score if you want to evaluate a chatbot that is also very cheap to compute. So that's exactly the kind of model evaluation techniques we're looking for. And I think this is extremely promising. I've used their code base and it works. So I'm very happy on that end too. So I would recommend reading about that. Another way, like another field is like model architecture. Recently, the Mamba 2 paper was released. It's a very good paper to also learn more about this entire field of like non-transformer architectures. I think it's very educational in general, with a lot of related work and a technical but not too opaque explanation of what powers the SSM architecture. So that would be another recommendation for me.
Awesome, thank you. Um, Perfect. I know I said that we were going to go into career, but I'm curious to ask you that answer if you can. But when I look at the key companies building the biggest models, so you mentioned Mistral, Llama, Claude, you have OpenAI, which is closed source. I don't know. Then you have like a lot of models, Hugging Face, Anthropic, and so on. Many of them. But what are the key phases or key advantages that is required to be number one? Like, how do you compete to be the first, or like to have the state of the art model with all the challenges that it implies, like having in the training some eval sets? So I've heard in some podcasts that you can see that, you can detect it, and so but it seems quite complex, and so I was curious to ask you about if you can answer at some high level or not. I would be curious to know what you think about it and what are like the most important things.
The single most important thing that these companies have is compute. You need a lot of compute to be able to compete at that level, because these models require very long training phases. So compute is definitely needed to scale. And the other main advantage that they have is high quality data, because even if you have the compute, if you train it on low quality data, it's not going to help you that much actually. So the quality of the internal data sets is also very high, which is why they have very strong results. This is definitely a very important aspect. Then every company has a kind of secret sauce, secret techniques that are not disclosed. So it's quite difficult to talk about that. But I don't think that there is any major breakthrough in this area. It's mostly individual techniques that they realized were effective with experiments. So this also shows that the open source plays catch up with that and can really discover or rediscover all these individual techniques, and that's really good. Recently, I want to also recommend third recommendation, the FineWeb Dataset, Hugging Face, made an excellent blog post about how it was created. And they also talked about a subset of this fine web pre-training dataset with, if I remember correctly, 15 trillion tokens. They created a subset with 1.3 trillion tokens that is called Fine Web Edu. And they realized that if you isolate all the educational content from the original pre-training set, you have a smaller subset that is extremely high quality. And if you train models on this data set, you see that the performance grow a lot faster than with the other data sets. So it shows that there's still like a lot of untapped potential in these data sets for training or for fine tuning. There's a lot that we can do to make these models train in a more efficient way.
I see. I see. And so if I think of closed source and open source, uh, how do you explain in general to people around you what's the importance? I know I asked you earlier the importance of open source and so on, but when you compare closed source and open source, and like you said, like each big company have common methods that are shared, but also some secret sauce. And this is kind of the bits that they do, I assume, taking into account that they have all some limitation in GPU, some more than others, I guess. But yeah, how do you see closed source versus open source, and how do you think that this competition between the two and the scalability of one and the other will impact the field and the industry in the upcoming month or years?
Yeah, it's a good question because we see that the open source community grew a lot during this past year and is now able to get better models than GPT 3.5. So we really have a plot where you can see the best models produced by the closed source and the open source worlds. And you can clearly see that we had a lag of about 6 months between both fields. So based on that, you can say, oh, okay, that the open source world is slowly winning actually because we're getting better and better. You have to also realize that the pre-trained models, they come from companies like Meta and Mistral, who are also that are also part of the closed source world. So it's a bit of a gray area, and I can't really say that there's a real competition between both. It's more like open source is very important because everything is transparent. It's actually science. When OpenAI publishes a technical report about the new GPT model, it's not science. It's a company that is selling you a product. So it's really two different approaches. I believe that open source is very important to understand how these models work, how to make better models, but also maybe how to implement safeguards, how to make sure that they're not used for malicious purposes. And yeah, open source is more like common goods, and you can be sure that everything that is open source will also be used by closed source companies because this is a major source of inspiration, and you have like a lot of tools, techniques that have been released and that are now adopted by AI companies. For example, Flash Attention 2 is now like a standard in the LLM world, and that comes from the open source community, or to be precise, like a company that decided to open source it.
Yeah, yeah, I think that's very important for many reasons. But uh, I'll skip my thoughts and I'll directly go to career side. So you have a very impressive career. You've worked at big companies and you've been in the LLM space for some time. So I think you're one of the best people to talk about like how should people get into the field, what should they do, where should they go, what should they look into. So I know that we've shared some resources throughout the episode. We shared some concepts, but basically, if you were to give advice to both a beginner in the field that is very curious about ML in general and specifically LLMs, but also someone that have, let's say, 5 years in the field or maybe more advanced, but how would you mentor, or what kind of tips would you give to both profiles?
I think that the most useful tip would be to create your own project. So based on your experience, you're gonna have like different projects probably. Find something that really inspires you, that you really want to build, because like if you do things in the open source, like motivation is the only thing that matters really. Start small. There's with very focused projects that are really really easy to do. Don't start by trying to pre-train an LLM that is really too advanced really for a single person to do. So like start very small, use tutorials, articles online that you enjoy. For example, you can have a project that is, oh, I want to fine tune a model for this specific task, like for role playing, for like to be proficient in a language that is not that common in this field. So that could be a nice little project that you can do. You have pretty much hopefully like all the resources, and it's more about like assembling these resources to make something, and then based on that you can slowly start expanding and create more ambitious projects. One of these projects could just be like writing an article, because it's very common to say, but writing articles is the best way to learn something by explaining it to someone else. This is what I do all the time. I keep writing articles because it's also the best way for me to learn about it, to motivate me also to dedicate enough time to really delve into it and learn more about a topic. And that's also very rewarding, you know, because then you have people telling you that they appreciated the article, they implemented it, and that's really a good way of contributing to the open source community through education. Um, Beyond model and articles, there are like a lot of things that you can do depending on like your previous experience. For example, if you have a background as software engineer, we in a clear lack of good tooling in the LLM space. So there's a lot you can do. Personally, I saw like a few issues that I had with the current tooling. For example, I found that it was quite difficult to evaluate models. So I had a little project called LLM AutoEval, which is just a Google Colab notebook with a little library that allows you to input the ID of the model on Hugging Face that you want to evaluate, select a benchmark, click on a button, and it's going to create a RunPod instance and do the entire evaluation for you and upload the results on GitHub. That was super useful to me because I needed that to quickly evaluate a lot of merges that I've made. And then I decided to just release it in the open source, and people started using it, including companies, researchers, that kind of stuff. So that was also very rewarding. I think this is the kind of project that you see like a clear lack of tooling, and there's a like really major contribution that you can make in this space.
Right. And all the cool things that we can build in open source really seems that to come from, okay, I'm going to solve my own problems, and then I can share the solutions, or I can sell the solutions. Both way are interesting to explore. But yeah, and I like how you mentioned that in the beginning it was just a little Google collab. And I think that it's super cool to just play around with concepts, grab like a notebook and just start playing with things and then make it bigger. And yeah, I think you thank you for sharing all these tips. That they are super interesting, and I think I could go on and on asking so many questions. I have my closing round of two little questions for you, Maxime. If you're still at this point in the episode, that means a lot. Thank you for sharing this time with us. Feel free to leave a comment and share a like if you enjoyed this content. If not, well, don't leave a like and share it with us anyway. So I think my two last questions for you, Maxime, is first of all, where can people reach out to you, learn more about you, your book, your blog, and so on? I know that you have a lot of links in your LinkedIn. We'll put links in the descriptions, but I don't know if you want to mention a specific place.
Yeah, in terms of social media, LinkedIn and Twitter are the two that I used. I also have a blog that centralizes everything that I write, if you're interested in that. And also on GitHub and Hugging Face, if you're interested in the tools, the LLM course that we mentioned, or the models on Hugging Face. Maxime Labonne, you can find me on these platforms.
Awesome. And last question, Maxime. Do you have a message for the Let's Talk AI community? So it can be anything, some things that we said in the episode, something personal, something self-development, I don't know, anything.
Yeah, sure. I think that we in a field, the AI field in general, that is growing at an incredible pace, and this growth will not stop in the 2 coming years, from what I can tell. So based on that, I think there's a lot of things that you can do if you're interested in this field. Education, like how to become better in your job, and in terms of careers, there are a lot of opportunities on the job market that you can seize. And based on that, like really, if you're into that, if you enjoy training models, creating data sets, writing tools, there's a lot of potential. And I'd be really happy to see like what you can create. I would be happy to read the articles and use your tools. So please feel free to contribute to the open source community. For me, it was extremely rewarding, and I'm sure that if you dedicate the time, it will be extremely rewarding for you too.
Amazing. Thank you very much again, Maxime, for your time. We should have an amazing day and see you on the next episode.
Thank you, Thomas. Bye bye.